Good afternoon, everybody. Are you awake? Yeah. Okay, thank you. My name is Shantilal Morar. I'm a technical director for Thales. I've been with Thales over a quarter of a century, so a long time. I've been involved in many delivery and design of systems, from Vancouver SkyTrain to Vancouver Canada Line to JFK. They're all driverless automatic systems, so I'm glad that I've been involved for that long. And what we're going to talk about today is really resignaling. And one of the first resignaling projects we really did was back in the early 90s for DLR, which is in London, which is called Dockland Light Railway. So that's what we did, and what we are about to see here is the experience we have gained in resignaling systems in London. So this triangle is just a very simple information why we resignal. So in London and other places where the land is premium, in order to build a new system, you need the land and constructions and everything else that goes with it. And really the investment that you put in, and the only thing you're going to get back from it is really the operation of the railway and the maintenance. So that's why whenever we do a resignaling job is really to provide the return on investment that the the operators need. So for a resignaling system, let's look at that. What is really the customer really needs? The very first thing they want is the safety. They want a safe operation of railway, and that meets the current standards. Many of the resignaling systems, you'll find out that they are almost a century old, half a century old. They've been designed and built to very old standard or no standard at all, and therefore it is very critical that we have to now meet the new requirement. Their primary goal is to, they've grown, they need the extra capacity. They need to also plan for the future ridership, like in London, like in Paris. So improve performance and capacity with existing infrastructure. So what our system does and what we do is deliver the system without having to change the tracks, without to add extra tracks. Again, it's a shorter journey, faster journey, and higher throughput. One of the important part about enhancing to the high technology is availability, maintainability, and availability. Again, customers' needs are very high now. They want to run the train 100% of the time. There were new technology for enhancement to their efficiencies and operator flexibility. We talked about flexibility in terms of adding more trains and everything else, and moving back the trains in depot. Vancouver SkyTrain and the Canada other lines and JFK, they have automated depots since 80s. They can go in and out. They can launch trains from the sidings if there's any train broken. So that flexibility is already there, and that can be provided. It's got richer functionality. Richer functionality is just not in terms of the MMI, HMI at the user level, at the operator level. Also, we need to think about, especially in the North American market or area, also in Europe, is the adhesion, rail adhesions, slip slide, wear and tear on the wheels, wheel flat. So we need to provide functionality and facility to allow that train operation to be smooth and good, right? And we also need to provide decision tools when things go wrong, when the train are about to break, and that's important that we do that. So predictive maintenance is critical, that we provide the tools and recovery from the service of perturbation. I think I'm going to talk about the predictive maintenance tool, but I think we need also prescriptive maintenance. I think once we get to know the customer, once we know the asset engineer, we can go to the next phase of prescriptive maintenance as well. The most important part of it is for resignaling is really they would like to continue running the railway in the legacy system and provide us access to the railway to install our equipment. And that's normally done engineering hours at night. And they're not very keen on closures that are during weekends or during the weekdays as well. So what are the challenges for implementing a brownfield site? One of the biggest things is the migration from existing operational system. Do we do it as one big bang approach, or do we break it down to a smaller part and grow on it? This is a two-way communication between customer and the supplier in terms of how we deliver this system. I know there's a Chelsea fan who's looking at me there. Limited knowledge and documentation and legacy. Again, I'll come back to that in a minute, especially places like London, where the system is now 100 years old, 50 years old. Documentation doesn't exist. Document did exist, but in people's head, they probably have left and probably pushing daisies as well in many cases. But again, these are the limitations we have got with the brownfield side. One other thing is the behavior and rules. A lot of people have a legacy, their way of running the railway, and we have to work with them to provide them very similar way of running, but very efficiently. So that's one of the things that we have to work with them, and they provide the requirement for that one. We talk about limited access. Again, we have to work with that to deliver the system within a time scale. One of the things that we have every night going into the tunnels or into the railway and installing the equipment is to return the railway back to the operation. So in the morning, they're back to normal legacy signaling system operations. So it's very critical that we do this properly and efficiently. And another part of it is in many railways there is mixed mode operation. So what happens is that alien train running, i.e. trains which are non-London Underground in the case of London and London Underground trains. So they are running side by side on the same track, and the signaling system is provided for them as well. So there's fixed block system as well as moving block system, and they can switch between the two, where the moving block system can run behind a fixed block train and providing the throughput that is needed. So again, that's a design that is needed for this typical resignaling system. They're also very keen on early demonstration. So they are very keen to see that technology they have selected is going to work. So they normally do this on a train in a test track, and we very quickly prototype the system and run the train in ATO. And we normally do that within 3 or 4 months of getting into there and providing us a train and the system, and we can prove that it is going to work the way they wanted it. Another thing with the brownfield side is they already have a multiple number of trains, some of our old, new, mid-range trains, number of engineers trained. They all have to be upgraded. They all have to be equipped with a CBTC system so they can move on the railway. Again, we talked about like standards. We have to meet the current standards on a legacy railway. Now that is a lot of issues relating to earthing, to buffer stops, to the speeds. There are a number of things we have to resolve, and we work together to do that. So let's talk about Jubilee Northern Line in London and what's the case study. It was a very mature and complex railway. Jubilee had a number of operating signaling system. One was JLE, which was the new system between Green Park and Stratford. Then the other part was run under Metropolitan Line signaling system, and the rest of the line was run under a conventional system. Again, as part of the migration, we had to migrate through section by section such that it supported that. In addition to that, on Jubilee Line, we also had the platform edge door, platform doors to control, and therefore we had to also interface to that. Complex operation and interfaces and timetabling. Again, because they have a various separate signaling system where the trains are handed over from one to the other, we also had to make sure that during migration we also adhere to that. Again, we're talking about migration, working and delivering the system. We have minimum impact to the revenue. So even though we're migrating from new to the old, we have one part of the system under CBTC, the other part in legacy. We make sure that we transit from one to the other and seamlessly, and the people on the train or the driver would not note the difference. So statistics about Jubilee Line: 35 kilometer in track length, 25 stations, altogether 63 trains, 2 depots. We had a new operating center which we had to equip with. All operations were under ATO. Okay, it was also providing PM driving for manual driving as well. And there were, for this particular line, we had originally 5 migration sections, but later on, because of a time scale, we collapsed that into 3 migration sections. So that's what we did. On Northern Line, this was a longer line with a 58 kilometer with 58 stations, 106 trains with 5 depots. Again, brand new control center that was built, ATO operations, and this was again done in a 6 migration section, and it was a very complex railway, so a lot of complex junction as well, so that was done on the 6 migration section. So what is this simple existing drawing? Really, this is not to show you the train moving. Really, this is the time when the contract is awarded. That's when you do your survey. London Underground or any other projects around the world which are, half a century or century old, there are a lot of things out there which you do not know. It's not documented, and very people know about it. In order for your equipment to be installed, you need to go there and survey the railway and understand any equipment that is there which is interfering with your equipment, or may interfere with the equipment in terms of frequencies, EMCs. Again, drainage is important. You might want to put something on the track and they have a drainage system, and now you have to figure out what to do. So there are a lot of legacy things, like example, London is very old, therefore, the walls and that are not exactly meant to hang things on. So again, we have to work with them to make sure that we have got the right level of strength and durability where we can put our equipment. So this is the main time when you can get everything right, because if you don't get that right, you're gonna pay the price later on by reworking and reworking. So this slide more or less shows the passive installation which is done at night. So if you can see, there is another SCR room, which is a signaling equipment room, which is one in the red, and the existing IMR, which is interlocking machinery room, which is an old legacy system with a relay-based fixed block system. And what we do at night is one by one install equipment on the track side and also equip our CBTC SCR room with our equipment. One of the critical part we also install is so-called COC, cutover cubicle. And the idea behind this one is to make sure that we can move seamlessly between the legacy system and CBTC during night testing and during trials and weekend closures if they want to do that. So that's the reason, and we'll show that later on as we move along. So this is the weekend and night testing. So what we do here is we move the switch cutover cubicle back into CBTC mode, and we do all our testing at night, and allows us to debug our system and resolve problems before we go into commissioning of the system. And when we have done all that, we are ready for commissioning. So as you can see, the one in the green is we remove or decommission all those equipment from legacy system, and now the trains are running fast and quick and efficiently. That's the system that we delivered for London, Jubilee and Northern. So what did we got out of this resignaling in London? Really, return on investment is that we had improvement in capacity increase, 33% on Jubilee and 20% on Northern Line. And journey time reduction, 22% on Jubilee and 18% on Northern. We could have had a lot more on Northern, but there are tracks on Northern which requires enhancement in terms of layout and improvement. Once they do that, we'll get a better speed and we'll get a better throughput. In terms of minutes and time, I think Jubilee, you can get into the tens of minutes in terms of reduction, and Northern Line is on a similar state. So I mean, it's a great achievement in just re-signaling with the CBTC system and achieving a great increase in capacity and increase in journey time. Okay. Oh, sorry, reduction in journey time. So what's the conclusion from our work with the LUL on this project, really? First of all, the most important part is manage the risk. Most important is understand the requirement and interface risk. So very early on the project, we go through with the customer and understand what the requirements are. It is very critical to do that, because it may be a very simple one-liner, but it means a different thing to different people. So it is working with them to make sure that they mean what they mean, all right? We then work with them in terms of identifying the migration sequence. We go from north to south, east to west, whatever the case is, where the boundaries are. It is very important because LU or the operators themselves have restrictions. They have a driver training, they have a restriction on driver, how the rules are in terms of their training the drivers. So that allows us to make sure that our migration boundary meets their needs as well. Hold open discussion. Don't be shy. Make difficult discussion up front. If you don't, you're only going to pay the price down the road. So it's very, very critical that we do that upfront. The next thing is involvement of operators and maintainers. Very critical that we do that upfront because all that requirement, how they run it, it is important that we do that. Maximize system proving in the lab. Have excellent simulators, prove your system and software in the lab so you don't have to do that on track because it's very expensive for the track. And again, pay attention to the standards, it's critical. So in conclusion, one team approach works. There is solution to every challenges. Collaboration with them really, really helped to quickly resolve the problems, reduce the risk. Most important is a win-win. Always ask which party has got the expertise because sometimes the contractor has got the expertise, sometimes it is the supplier of the other contractor has got expertise, sometimes it is the LU themselves who has got the expertise to help you out. Consider whole life support, not just a signaling delivery, end to end. And whole lesson learned on a regular basis so you can learn from it and improve upon it. And adopt one team working from day one. So success continues, and with the lesson learned, we won the UK National Rail Award for outstanding teamwork. So it's LU and Talas together, we won this as an award. It was an excellent achievement. So what we have achieved from that, working with the customer, working together as a customer, as one team, we strengthened our relationship. In July of 2015, we were awarded signaling contract for the 4 lines, which is the Metropolitan, District, Circle, and the Hammersmith and City lines, which is more or less 40% of the LU assets. And the challenging for this project is we have to achieve 32 TPH for the central section, and at present it's 27, and increase the capacity by 20%. Again, our team is a long-term goal is to work as a partner and continue collaborative working. So a new challenge for the following project is 330 kilometer track, 191 new trains. There are 2 types of trains, 7 car and 8 car. There are 4 major depots and 2 major sidings at the for the minor sidings. Our delivery is signaling system is through the radio comms, and our positioning through transponders. We have mixed mode operations, CBTC and non-CBTC on many part of the tracks. We also allow the line movement from one track to the other. So because London Underground has got 11 or 12 lines, we allow the trains to move from one to the other. And we are collapsing the 16 existing control center that exists now into one. So that's our delivery goal for this 4LM project. And I'd like to thank you for your attention. Thank you.